Hi friends, welcome to all. In this video, we are going to configure CCNP ENCOR Packet Tracer Multi-Area OSPF v3. Dear friends, if you find our videos helpful, we kindly request you to like, share and subscribe to our channel. Coming to our activity, here we can see our addressing table, device interface, then we can see IPv6 address. Also given OSPF area. We are going to configure RA, RB and RC based on this OSPF area. Objectives: part 1, configure OSPF v3. Then in part 2, verify multi-area OSPF v3 operations. See, in this activity, we will configure multi-area OSPF v3. The network is already connected and the interfaces are configured with IPv6 addressing. That's perfect. Your job is to enable multi-area OSPF v3, verify connectivity and examine the operation of multi-area OSPF v3. In the previous videos, we have seen this OSPF with the IPv4. So here we are going to do with the IPv6. So as per the instruction, they configured all the interfaces with the IPv6 addresses. So we need to configure only OSPF v3 and we need to verify the connectivity. Okay, coming to part 1, configure OSPF v3. Step 1, enable IPv6 routing and configure OSPF v3 on RA. So here we can see our router RA. Enable IPv6 routing, then configure OSPF v3 on RA with a process ID of 1 and a router ID of 1.1.1.1. We will do that. Coming to our router RA. Enable configure terminal. We will enable this unicast routing IPv6 unicast-routing. Also, we will set the router ID. We need to give IPv6 router OSPF process ID 1. Then we will set the router ID 1.1.1.1. Next is step 2. Advertise each directly connected network in OSPF v3 on RA. Configure each active IPv6 interface with the OSPF v3, assigning each to the area listed in the addressing table. So here we can see RA interfaces G0/0/0/1 and serial 0/0/0. And also they given the OSPF area. So we are going to do this configuration here. We will go to the router RA. We will go to the interface G0/0. Here we can see RA interface G0/0. And we can see we should configure OSPF area 1. Okay, that's fine. So we will give the command IPv6 OSPF, then process ID is 1. Then we need to specify the area. So here we can see area is 1. Next, we will configure this interface G0/1. So we need to go to that interface. So here we can see we get some message loading to full, loading done. Because here we have some other routers which is already configured OSPF v3. We will go to the interface G0/1 and we will give IPv6 OSPF process ID 1 area 1. Press enter. Here also we can see this message neighbor 12.12.12.12 on gigabit Ethernet 0/1 from loading to full. Loading done. Here we can see these two interfaces. G0/0 is connected to this area 1 in this cluster, and G0/1 also connected to this cluster, maybe to the a router. And also we can see we given as OSPF area 1. Next we'll configure this interface serial 0/0/0. We can see interface serial 0/0/0 which is connected to this RB, and we can see it is in area 0. Yes, they specified that here in this addressing table. We will go to that interface serial 0/0/0. Then we will give IPv6 OSPF process ID 1 area 0. We will save the configuration and copy run space start. Coming to step 3, configure OSPF v3 on RB and RC. So here we can see those routers RB and RC. So repeat step 1 and 2 for RB and RC. The router ID for RB should be 2.2.2.2 and the router ID for RC should be 3.3.3.3. First we will configure on this router RB. We'll go to our addressing table so that we can see its interfaces and also its OSPF area. And here we can see all the interfaces are in OSPF area 0. Enable configure terminal. We will enable IPv6 unicast routing. Then we'll go to IPv6 router OSPF process ID 1. Also we will set router ID 2.2.2.2. Next we will advertise directly connected interfaces in this router RB. So here we can see G0/0, then two serial interfaces, serial 000 and serial 001. First of all, we will go to interface G0/0 and we will give IPv6 OSPF 1 area 0. Here also we get some message process 1 neighbor 21.21.21.21. So this router may be inside this, obviously inside this area 2. Sorry, it's in area 0, right? We are configuring RB. Perfect. So it's in area 0. Now we will go to interface serial 000, which is connecting to this interface, to this router RA. So we will enable IPv6 OSPF 1 area 0. Then we'll go to interface serial 001. Okay, we get this message. Process 1 neighbor 1.1.1.1, our router RA. Now we will go to the next interface. Interface serial 001 and we'll give IPv6 OSPF 1 area 0. And copy run space start. Same way we are going to configure on RC, and here we can see three interfaces. G00 going to this cluster, then G0/1 that also going to this cluster area 2. So those two interfaces G00 and G0/1, they are in OSPF area 2. And we can see a serial interface 001 which is connected to RB, and we can see it's in area 0. So we will do the configuration on RC. Enable configure terminal. We will enable IPv6 unicast routing. IPv6 router OSPF process ID is 1. Then we will set the router ID 3.3.3.3. We will go to the first interface G0/0. IPv6 OSPF 1 area 2. Yes. Here also we can see loading to full, loading done, neighbor. The router inside this cluster, area 2. Interface G0/1. IPv6 OSPF 1 area 2. And here also we may get that message if they configure on that router. Yes, here we can see neighbor 32.32.32.32 loading done. Next we will configure interface serial 0/0/1. IPv6 OSPF 1 area. See that this is area 0. Yes, loading done, neighbor 2.2.2.2. And copy run space start. Yes, we configured multi-area OSPF v3. So now in part 2, verify multi-area OSPF v3 operations. Verify connectivity to each of the OSPF v3 areas. From RA, ping each of the remote devices in area 0 and area 2. We'll go to RA. Ping. We'll try to copy this IPv6 address and paste here. Yes, success rate is 100%. Now we will ping to 2001 db8 1a1 :2. Yes, we get the replies. Next is A2. Perfect. Next is a C1. Ping. Here it's a C1 :2 2001 db8 1 C1 :2. So success rate is a 0%. We will try to ping to the next IPv6 address, that is a C2 :2. So I think here also we are not getting the communication. So these two addresses C1 :2, C2 :2, which are inside this cluster. So if I send a message from here to here, we can see successful. From RA to RC1, RC2. Okay, it shows failed. We'll try from RC to area 1. That also failed. Okay, what we will do, just we will restart all these devices in Packet Tracer. Power cycle devices. So configurations not in the startup configuration will be lost. Reset the network will give yes, because we already saved all the configurations on RA, RB and RC. and we will wait some time to converge this network. Now we will test the connectivity. Just I will copy this IPv6 address, go to RA, enable ping that address, IPv6 address C1:2. Yes, now it works. Actually, I just restarted all the devices because of its, it's in a packet tracer. We may need to restart all the devices. Also, we can ping to C2:2. Yes, it works. So I can send a message from RC to area 1 devices, RA1, successful. Then from RC, RA2, successful. Perfect. So here use show commands to examine OSPFv3 operations. Use the following commands to gather information about your OSPFv3 multi-area implementation. Show IPv6 OSPF, show IPv6 root, show IPv6 OSPF database, show IPv6 OSPF interface, then show IPv6 OSPF neighbor. They given a note. Packet tracer output for show IPv6 protocols is currently not aligned with the iOS 15 output. Refer to the physical equipment labs for correct show command output. Yes. So many of the commands will not work with our packet tracer. So those commands will work with our physical equipment, our real router. So we'll go to RA. Show IPv6 OSPF. So here we can see the output for this show command OSPFv3 process ID 1, and we can see the router ID. Okay. Now we will give a show IPv6 root so that we can see all the remote networks learned with the help of this OSPF. Okay, here we can see the same area, and here we can see this OI. Inter OSPF, right? OI, which is not in the same area. So here we can see 2 OI on RA. This route is from area 2. Next, we will give a show IPv6 OSPF database so that we can see databases here. Show IPv6 OSPF interface. We can see the cost, hello timer, death interval timer. Show IPv6 OSPF neighbor. So we can see on this router RA got 3 neighbors. Here we can see those router ID 2.2.2.2, that is RB. Then these 2 routers are inside this cluster. So we have seen that named RA1 and RA2. Perfect. So that's all in this packet tracer activity. Configure multi-area OSPF v3. Now, dear friends, if you find our videos helpful, we kindly request you to like, share, and subscribe to our channel. We will meet again with the next video. Thank you.